Welcome to the second part of our video on drawing a scatter plot and interpreting it. This video, is focusing on once we've drawn the graph, what do we do with it? How do we interpret it? And this is mainly for those students in year 9, 10, 11 and 12. So once again, we'll very quickly draw our graph. So here's our data that we're working with. We've got our temperature, our independent variable, which will go on our horizontal axis, and our dependent variable, the value we measured, will go on our vertical axis. So very quickly, I'll just draw that graph as a scatter plot. So we insert the scatter plot, the first option. Okay, I'll just change the title, effect of temperature. I'm just going to put a temperature blah, 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 because I don't want to waste too much time. You put in the full temperature quite obviously. We select our axis titles. Okay, the temperature one goes on the horizontal axis, so I'll very quickly whack that in. If you don't know how to do what I'm doing now, please go back and watch the first video so you can see how that works. And there we are. Okay, so I'm going to make this graph a little bit bigger so we can see it more clearly. Okay, so there's our scatter plot. So once we get to grade 11 and 12, we're going to be starting to look at modelling this. So in other words, working out, or even grade 10, working out the equation that maps that. Now, if we look at those dots, we can quite clearly see that it's linear. Okay, those dots form a fairly good straight line. It's not perfect, but it's pretty good. So we can get Excel to do some work for us. So we're going to go back into this little plus sign up here. So I'm going to click on the chart elements. Okay, and the first thing we're going to do is we can add some more grid lines if we choose. You'll notice we can slide down and you'll notice this little arrow. So we click on the arrow. I can put in some more grid lines, primary, minor and primary, major, and we can see that there are more grids here. If you then want to print that off and draw your graph in yourself and calculate your line of best fit, then you can do that. But we can also use Excel's functions to do that. So once again, we click on the plus sign. We go down to trend line and you'll notice a line appears because by clicking on this little arrow, and then we go to more options. You'll notice on the right, we have an option turn up. Now, we want to go into the graph choice. Sometimes that comes up automatically. Now, in this particular case, we believe that this graph is linear because it follows a straight line, and that's the default. That's what comes up automatically. We can change to others, and when you get to year 11 and 12, you'll explore these other models. But for this case, we're looking at a linear relationship. Now, we can also ask the graph to come down and choose and write the equation on the graph. And we're also going to display this thing called R squared value. And I'll explain what that is in just a moment. Now, we'll just close it off so we've got some more space. All right, so there we've got our graph and we've got some values. Now, if you have a look at our graph here, we can see that the equation for this graph is y equals, so y in this particular case is our mass. So that would be our mass is equal to 1.55 times our x value. So 1.55 times the temperature plus our y-intercept, 0.95. Now, you'll notice that the graph doesn't pass through every point. This is what we call a line of best fit. Excel has decided that this is the line that best represents the graph. Now, you may choose to do a different graph. This is the one that Excel has done. And we can use this as a fairly reasonable approximation of the data. Now, because the line doesn't go through every point, that's fairly typical. Experiments don't usually work perfectly. Then you'll notice over here we have this thing called an R squared value. Now, this is called a regression number. The calculation is probably second or third year university, so we don't need to worry about how it's calculated. The point is, though, that if R squared was equal to 1, then every point would be exactly on the line. In other words, you could draw a line perfectly through every point and there'd be no gaps. However, you'll notice here that our R squared is 0.9954. Now, that's very close to 1, though you don't usually get an R squared much less than about 0.9. If you do, your relationship, then it wouldn't be linear. It would be something else completely. So 0.99 is perfectly acceptable. Anything above 0.98 is considered acceptable. Anything less than 0.98, you've probably got some problems with your data. So that is our relationship. And once you've determined your relationship, your equation, then you can take that and you can manipulate that and do some other things with it. But that's beyond the scope of this video. So a reminder, it's in plus in trend line, choose more options, and then you scroll to the bottom and you tick display equation, display R squared value.